Are we going to get fractions for the third one or a mixed number?
Decimals.
You know what? Like, can't we use fractions? I want to use fractions.
Okay, fine.
See, your mind's meeting you up. Number one, you won't leave a problem. How he just said that isn't just supposed to break the
Okay, so you have 1 more minute for the warm up.
No.
Sounds wrong.
I'm trying to help him. No.
Hands if you need more time. Okay, 1 more minuto.
So on number 1, I did it this way, but if you were to switch these numbers, so the 8x here and the 3x, you get a different answer. So
Yeah, but what is GCF here? X, or you're left with 2x minus.
oh, okay.
He doesn't know me so much.
Be nice.
You just question your rule. The quiet on the computer, she's like, she put a leg on my desk.
So you're trying to get a leg up on the competition? Bam.
No.
All right, here we go. Number 1. Nina, what'd you get? X plus 4. Oh, sorry. X plus 4, parentheses. 2x minus what? Minus 3. Hands if you got that for your factors. That is correct. Number 2. Pass to someone, Nina. Cassie, what you get?
M equals -4. B equals 2.
Hands if you got that. M equals -4, or -4 over 1, and B equals 2. That is correct. Pass someone. Axel, what'd you get for the plane speed?
Plane speed is 187.5 miles per hour.
And the wind speed?
So wind speed is 37.5 miles per hour.
Hands if you got that. That is correct. Spirit fingers on 3. 1, 2, 3.
I'm not doing this anymore. Yeah.
All right. Look up, please. Just to double check, look at number 2. Number 2, first we need to solve for y, which means I need to get rid of this or send the y to the other side, but let me get rid of this first. Plus 24x minus 12 plus 24x minus 12. My goodness, computer. Okay, my bad. So this is -6y equals 24x minus 12. Divide by -6, and we get y equals -4x plus 2, and that's how we get our slope and our y-intercept. Yeah. Yes, or you could add 6. That's what I said at the beginning. You could add 6y to each side, but I just wanted to leave it as y form like this. Okay? So, get a blank sheet of paper out for Cornell notes. You do need a Freire model.
Is it going to be a lot of notes?
It's going to be
Is it going to be more than one page?
Yes, it's going to be more than one page. Yeah. Okay, can you read the objective for us, please? Brian, go.
I can solve and graph quadratic equations.
On 3, 1, 2, 3. So yeah, this is very similar to what we started with. We started with quadratic functions. Today we're just going to focus on quadratic equations. So we do need a fair model just to focus our attention to quadratic equations. So our objective, I can solve and graph quadratic equations. What are quadratic equations? Quadratic equations are two variable equations where the highest degree is 2. Bless you. Two variable equations where the highest degree is 2. Two variable equations where the highest degree is 2. Quadratic equations, two variable equations where the highest degree is 2. Two variable equations, highest degree is 2. Two variable equations, highest degree is 2. Two variable equations, highest degree is 2. Take note of the definition. Oh. Where? I already said it 3 times. Example. I know, Louis over here like being mean to me. X squared plus 3x plus 2 equals y. X squared minus 9 equals y. Y minus 6 equals 3x squared minus 11x. So according to the definition, it says two variable equations, highest degree 2. So notice here we don't have any more f of x. Even though the book is going to give you, for the home play, some f of x or f of n, whatever the case. But you know that you can change those to y. Is that correct? So, who notices here that we no longer have to have them specifically in y form? You guys notice that? Okay. Non-examples. X squared plus 3x plus 2, negative 3 plus x equals 10. So I'm pretty sure that would clarify why these are not quadratic equations and these are. So look at them. These are not because, tell your neighbor please, these are not quadratic equations because. Okay. Hallie, why are these two not quadratic equations? They don't have the equal sign, so they are what? Expressions, that is correct. How about this one, Gio? Why is this not a quadratic equation? Doesn't have a power of 2, or what else doesn't it have? A y. There you go. So with that said, who can give me a hashtag? Hannah.
2 variables.
2 variables. Christine? Equations. Francesca?
2 variable equation with the highest degree is 2.
No. Okay, my bad. Whoa. My goodness. Beto. Quadratic. And by now we know what a quadratic is, right?
Yeah.
The highest degree is 2. Very good. All right. Here go the steps.
Let me guess, there is no one.
Bam! Yeah!
We do nothing for something.
So, since we are going to need probably the entire page for this one problem, turn your paper over. Let's use the back side.
Wait, for the step, just 1 page?
No, for the example. Turn the paper over, example 1. Write this down. Matthew, you all right? Okay.
Oh, he came back too?
Example 1. Solve the quadratic equation by factoring and check your answer. They give us the equation x squared plus 8 equals y plus 6x. It says, example 1, solve the quadratic equation by factoring, check your answer. X squared plus 8 equals y plus 6x. Copy that. I'm sorry? No, I'm gonna go over the process. Okay? Okay, writing utensils down. So I'm gonna go over this step by step, and we're gonna be writing the steps as we go along. But let me first do the elaborating to the step. I'm gonna ask you some questions so that we can get our train of thought focused on each step. Okay? Now this is gonna encompass everything that we've seen throughout the year. So now we're gonna see how we have a lot of concepts and processes that we've learned from the beginning of the year till now, and how everything's gonna start meshing together really cool. Okay? So with that said, writing utensils down, look up to the screen. To get started, let me zoom in just a tad bit. And the instructions are solve the quadratic equation by factoring and check your answer. So I'm going to start with step 1. I'm going to be writing my steps here, but you're going to help me with that. But I'm going to do the step, and as I'm doing the step, I'm going to ask you some questions so you can start gathering your thoughts for step 1. Here we go. Before I bring this down and this down, tell your neighbor what this is called.
Standard for something. Yeah, standard for.
Everyone.
Standard for.
Step 1, you're going to write standard form. But we're going to combine it with this. Look up. What is this side? We solve for what? So in parentheses, you're going to write solve for y. Step 2. Okay? All right. Writing utensils down. Before I do step 2, I'm going to take you back to our second quarter of the year. Here it goes. Look up. Here it goes. Second quarter of the year, I remember when we got to, when we started two variable equations, that I gave you stuff like this. And then I asked you that we were going to graph using the x and the y intercept. Is that correct? And I showed you a method. Tell your neighbor the method that we use to graph using the x and y. So the method for this type of approach to graphing was the cover-up method. Who remembers that?
Yeah.
Okay. And I mentioned when we took that lesson that when we created a little table was the fact that when we cover up the y, we solve for the x-intercept. Is that correct? Or in other words, we cover up the y because 2 times 0 is 0. That's why we covered it up. Is that correct?
Yeah.
Does everyone understand so far? So by making y 0, that's why we covered it up, because we no longer have a y and we solve for x. Are we there? So here it goes again. Listen to what I'm saying. In order for me to get my x-intercept, what had to happen here? Y became what?
0.
Okay, so with that said, here they want us to solve the quadratic equation. Are we there so far? So let me ask you this. What is a solution to a quadratic equation? Don't say it out loud. What is a solution to a quadratic equation? We covered that yesterday. What is a solution to a quadratic equation? So if you were to graph it, tell your neighbor the solution to a quadratic equation.
That is on the x-axis, and it's not on the y-axis. It has to be that y has to always be 0. the parabola, it just has to be x-axis. Yeah, x-axis. There!
Okay. I heard some conversations and I heard people say when the graph crosses the x-axis. That is correct. Therefore, if that's the solution to a quadratic equation, what are these known as when a graph crosses the x-axis? Tell your neighbor.
Parabola.
When the graph crosses the x-axis, those points are called what?
The solution. The coordinate. Order pair. Right? Order pair. Yeah, but a solution is an order pair. It doesn't have to be.
Okay, I heard solution, yes, because that's what they are. I heard coordinates, yes, they are coordinates. But what would be the simplest way of saying this, Jeremiah? I'm sorry? Close, Hannah?
Ordered pair.
Yeah, they're ordered pairs, yes. X-intercepts. X-intercepts. Okay, so now that we have that wrapped around our brain, pay attention, please, or you're going to miss it. I said when we were in linear equations to find our x-intercept, we made y 0, yes? Okay. Think it over. What do you think my next step is in order for me to find my x-intercepts? Talk it over with your neighbor, please.
To make x, I guess. Because y is like 0 right now. But y is 0. But y is 0 right now. Because if you put a 0 next to it, it would equal the same thing.
Let's say Noel. Make y 0. That is correct. Make y 0. So then it's imperative that you understand that step. So then we end up with x squared minus 6x plus 8 equal to 0. Does everybody understand why we make y 0?
Yeah. Because it has no value, right?
Because it has no value and we need to solve for x. Is that correct?
Yeah.
Okay. Alright, now that we're at the step number 3. Writing utensils down, I'm going to go ahead and do the process for step 3. It's a lot of steps, but it's called something. So start wrapping your brain around to what would it be called, everything that I'm going to do next. Pay attention, please. Here it goes. Shh. Shh. Tell your neighbor what all this process is called.
Factoring.
Everyone? That is correct. So right for step number 3, factor. Factor. We're going to factor. So I want you to copy this, please. Yes. Yes.
Okay.
Everybody done?
No.
Excuse me?
Wow. And I know, and I usually tell like some of my friends are like, man, my 7th period is my nice class.
Are you trying to say something, Mr. Future?
That would be nice.
Wow. Oh, you guys caught the sarcasm? I'm not sarcastic.
Really? See, Mr. Can we totally believe you on that one?
All right. Okay, come on, tomatoes.
Why don't you call these Brussels sprouts?
Why?
I don't know, Brussels sprouts are good. I just thought it'd be good. I thought it'd be the fastest way, the shortcut. The shortcut.
No.
Wait, what was? Oh no, we can't use it. Oh, what was the shortcut? Was it the bacon
Yeah, we have like
and we're not fast. Do we have shortcuts?
Okay. All right, writing utensils down, please. Step number 4. Step number 4, I'm going to go straight to the beginning of the school year. In the beginning of the school year, I covered some basic properties. We started with zero pairs. Remember that? Identity property of addition, inverse property, and all this and that. And then we covered commutative property of multiplication, and we did other things. And then I kind of mentioned, you know, guys, whenever you multiply anything times 0, the answer is 0. That's the zero product property, but we'll get to that later. But everybody understands the property of 0, right? Anything times 0 is always 0. Okay, that's what we call zero product property. And the name itself should explain it. 0 product, that means you're multiplying times 0, and it's a property because it's always 0. Are we there? So now that we understand what we're talking about, let me elaborate, look up. You don't have to copy this next stuff. I just want you guys to get your brain around this before I do the next step. If I have A times 0, the product is 0. If I have 0 times B, the product is 0. But then, if I do this, what could A be? 0. Or what could B be? 0. Okay, so with that thought in mind, pay attention, please. This times this equals to 0. What could this be?
2.
Okay, here it goes again. A times B equal to 0. Yes? A could be 0 or B could be 0. This times this equal to 0. What could this be?
0.
X minus 2 equal to 0. What could this be?
X minus 4 is 0.
And when you put OR. Copy that step, and that's known as zero product property. Or I shorten it and I say it's ZPP. Yeah, you know me? Yeah?
Mr. Q?
Never mind.
Is that like a reference?
I know you're trying to know.
I'm trying.
Not to be mean.
Nice.
Is it you or is it like the person?
What's that?
What's OR?
OR is
Okay.
like this. Okay? Ready?
Yeah.
So I'm going to erase this part because this was just to elaborate on zero product property. Everybody understands why we did this, right? All right. Whew, almost there. Step number 5. Pay attention. Writing utensils down. Look up. And go back to the instructions. It says, solve the quadratic equation. These are my solutions. Therefore, what is step 5, everyone? For x. That is correct. Solve for x. And how come we only could solve for x? Because we made y what? 0. That is correct. Bam! I'm sorry? Yes, please copy that. Everybody done?
Tricky, what did it say after x intercept? Zeros?
Zeros, roots. So these are our solutions. This is what we were aiming for, right? But I wrote down here, also known as our x-intercepts, yes? In Algebra 2, they're going to start calling it your zeros, because what are the coordinates when it's x-intercept? What is y?
0.
That's why they're known as zeros. And roots, and I'll elaborate on roots right now.
Wait, why do they call it a 0 when it's a y? Because y is 0.
Because that's when it crosses the y-axis and the x-axis, and you don't have any value for, the value is 0 for y.
But then wouldn't they call y 0?
I don't know. That's what they call it.
Okay.
All right. So roots. Why are they called roots? Let me take you back once again to the beginning of the school year. Who remembers when we covered square roots that I said? You guys remember that? And I said, how can you guys remember finding the square root of 16? And I said, the roots of 16 are 4 times 4 or negative 4 times negative 4. You guys remember that? All right, because we can do this. Is that correct?
But why did you box the 16?
Because I'm making it a perfect square.
I thought you were going to do something with like a square, like put 2's or
All right, so with that said, math.
Yes.
Here he goes. Where are we at? Okay. So, let's say I wanted to find the root of this square or this rectangle, and it was so if this was this, what did we say we'd do? Yes? So if this was that, couldn't I do this? So what do I get? Whatever times whatever. And what are these called? Roots. So these are known as?
Oh, okay. Oh, is that why you broke it down factoring? Wait. No, I don't get it. So the factoring was basically like the square root where you broke it down.
Right.
Okay.
So here it goes again. We said that when we factored, we did the operation was division, right? But if we're talking about perfect squares, this one right here, the perfect square of 16, we find the square root. What are my roots? 4 times 4 or negative 4 times negative 4, right? So I could call these what? Roots. So if this was a perfect square, take the square root, whatever comes here and here, these are known as. So what are these? Roots. That's why they call them that. I know. We'll get there. We'll get there. All right. So we're almost done. Let's go to step 6. Nope. That's not it. Look up, please. Shh. Look up. All right. Before I get started with my graphing, by looking at that, tell your neighbor the y-intercept.
5.
Okay, everybody says what? 5. If somebody walked in that did not know any algebra, and they looked at that, and I asked the question, tell your neighbor the y-intercept, and everybody said what?
5.
5, and that person walked in and heard that, and they looked up, Why do you think they would think or they would know that that's the y-intercept?
Because it doesn't have a variable next to it.
Because it doesn't have a what?
Variable.
A variable next to it, right? Or it's a constant. So that's the obvious thing, right? Okay, let me go to our problem at hand. Tell your neighbor the y-intercept. That is correct, 8. And that's what we need. That's our first point that we need to get started with our graph. So our y-intercept is 8. Tell your neighbor, what other 2 points can we plot to get our graph going? Everyone? 2 and 4, because we know those are my x-intercepts, right? And now with those 3 points, I can graph my parabola, going from left to right. So step 6 is graph. Copy that, please. We're almost done? Yeah, almost.
It's like long division, not long division.
What's that?
It's like long division.
I know. It's just a long process.
This is simple.
Yeah, there's only 17 problems for home plate.
Only.
All of them like this?
No. I'll talk about it later. Okay, look up. Shh. Here goes the process once more. Step 1, standard form. Did we do that here and solve for y? Yes. Did we make y equal to 0? Yes. Why did we do that? Because we're finding the x-intercepts, right? Step 3, did we factor? Yes. Did we use zero product property? Yes, so that we can set them equal to 0. Did we solve for x? Yes. We found our solutions known as x-intercepts, zeros, or roots. Are we there? Step 6, we graph using the y-intercept and the x-intercepts. So what do you think our last step is, everyone? That is correct. Step 7, check. So for step 7, I'm going to write this equation right here. X squared minus 6x plus 8 equals y. And I'm going to write it again. X squared minus 6x plus 8 equals y. And tell your neighbor why I wrote it twice. Okay. Who can elaborate? Ivan, why? Let's do solution. What is my first solution? 2, 0. And what is my second solution? 4, 0. And now we have values to substitute and check. Is that correct? So instead of x, what do I write here? 2 squared minus 6 times 2 plus 8. And instead of y, 0. So let's see. 4 minus 12 plus 8 equals 0. Combine like terms. What is 4 plus 8? 12, bring down the negative 12 equal to 0. What is negative 12 and 12? 0. Is that equal to 0? Yes. Check this one. 4 squared minus 6 times 4 plus 8 equal to 0. This is 16 minus 24 plus 8 equal to 0. Combine like terms. 16 plus 8, that's 24. Bring down the negative 24. This is 0. Is 0 equal to 0? Yes. All right, let's check out the beautiful artwork. Bam! Look at that. Looks nice.
You like color, don't you?
All right, we finished example 1.
Oh, that was just
But it's because it took us long because of all the processes and the questions and the timeout and the writing. So this next one, you should be able to do this by yourself pretty fast. Example number 2. Copy this, please. On your other paper, I said we're going to need 2 papers, right?
Wait, why can't you?
Oh, if you have space, that's fine. Yeah, some of you that have small font. It's up to you. Here we go. Example 2. You don't have to copy the instructions. You copy the equation, and it says Y minus 7x equals x squared plus 10. And of course, the instructions are solve the quadratic equation by factoring and check your answer. So you know the process. Ready, go. See how you do. Thank you.
Can you flip it? You know what I mean? So like the y goes on the right.
Yeah, that's fine.
Okay.
Oh, actually.
Jillian,
No.
be nice.
Yeah. He's the one that wants to.
So you are struggling with the first part. Let me get you started. There you go.
Thank you.
There you go.
I'm really honest with you.
Be nice. Be nice. Should be close to solving without graphing, but you should be close, right?
We're not graphing?
No. I'm saying you should be close to solving already,
Oh, okay, okay.
I saw. If I'm excited.
but you need to graph, right? Okay, good. Yes.
I think I have graphing paper.
Well, because what if tomorrow? Pop party? All right. Pop party. Yeah. Pop party.
No.
No. Matthew, tell me what to write. Go.
Oh, add 7x on both sides.
Be nice. Continue.
Okay, so then that's y equals x squared plus 7x plus
Pass someone.
Lily.
Lily.
Yeah, factor. So it's gonna be. Okay, so it's gonna be 0 equals. Do I factor it too, or do I just do 1?
One step at a time.
Okay, then x squared plus 7x plus 10.
Pass someone.
Geo.
Gio. What do I do from there?
Let's do it 0. No. Wait. Yeah. No, you factor.
Thank you. Okay, what goes on top?
10,
Bottom.
7,
And the two factors are
5, 2.
5 and 2, or 2 and 5. Does it matter the order? No? Okay, tell me what to write.
X squared. 0 equals x squared plus 5x plus 2x plus 10.
Pass someone. Allie.
Okay, faster, put the parentheses. And then it's x. And then for open parentheses, x plus 2. Wait, oh, you're on the other one, 5. And then that would be 2, and then x plus 5.
Pass someone.
Hannah.
Hannah.
And then you.
Tell me what to write.
0 equals open parentheses x plus 2 close parentheses times open parentheses x plus 5 and close parentheses.
Pass someone.
Lisa. Lisa.
Lisa, continue. Tell me what to write. Continue. X equals -2. X equals -5. These are my solutions. X-intercepts, zeros, roots. Hands if you got that. Okay, pass someone. Question, Matthew, go.
Do we have to write like solutions, x-intercept, zeros?
Okay, yeah, let's write solutions, x-intercept, zeros, and roots. Yay! Jamilette, what do I do? Y-intercept is 10. -2, -5. I'm going to go from left to right. Hands, have you got that? Okay, and you know how to check, yes? All right, so, yes. Yeah, because that's a constant. Okay, now look up. Let me show you some other presentations the way they're going to present it. Look up. Look at this one. Look up. Tell your neighbor what goes on top and what goes on the bottom. 6 and 5, and you know what to do from there, yes? Look at this next one, though. Look up. Because now the coefficient needs to be included. Whenever you have a coefficient in front of the x squared. Whenever you don't multiply. Look up. Look at this one. Tell your neighbor what you notice on this one. Exactly. So on that one, you just do the last 2 steps, and that's it. So the home plate is going to have a lot of these. Look up. It's going to have a lot of these, but instead of this, look up. Instead of this, they're going to have this. Tell your neighbor what to do from here. Change it to 0. Yes? All right. Home play for tonight. Home play is on page 577. Thank you. I'm going to stop the broadcast at this point. Everybody say bye to Charlotte. Bye, Charlotte. And bye to Ethan.